there! Today we'll go over asynchronous programming in JavaScript. So, what is it? Well, it's important to understand that JavaScript is single-threaded, which means one operation executes at a time. Asynchronous programming allows for operations that otherwise may have blocked the program to operate behind the scenes and not block the call stack. So, JavaScript has a call stack, which tells it what to execute. So when a function is called, it's added to the call stack, and when it's executed, it's taken off the stack. Well, what's interesting is that asynchronous operations are passed off to web APIs provided by the browser to handle in the background, so that the call stack is not blocked. When the operations are completed, they're placed onto the callback queue, and with the help of something called the event loop, which determines when to place the operations from the callback queue and onto the call stack. And it'll be placed onto the call stack when the call stack is empty. So just a few common use cases for asynchronous operations might be getting, posting, updating, or deleting data from external sources, file operations, as well as waiting on timers to complete. Originally in JavaScript, callbacks were common with dealing with asynchronous operations, but it led to something called callback hell. And two modern approaches are promises, and those can be used in tandem with async await. And another pair of asynchronous functions are setTimeout and setInterval. So how do we make an asynchronous function? So to begin with, I have a delay function over here that creates a promise and resolves the promise after the number of milliseconds that are passed into the function. So a delay of 2000 would take 2 seconds. Now over here, let's make our own. We can use the async keyword in front of the function declaration, making it an asynchronous function. This then allows for us to use the await keyword. The await keyword can be applied to an expression that results in a promise, and it will pause the execution in the function until that promise resolves. But because it is an asynchronous function, we are not blocking the call stack. So we can place it in front of the delay call, which will create a promise, and with a value of 2500 passed into it, will resolve the function after 2.5 seconds. Now, I'm going to hit save right now, and what we will see is that there will be a quick delay before the function is resolved. Cool, on to some theoretical questions. How do you catch errors in promises? You can use a try-catch block, which allows for us to try a block of code, and if an error occurs, we then handle the error in the catch block. What are the issues you may run into using await inside of loops? So we have to wait for each sequential operation to finish before going to the next one. So at each iteration, we wait for the promise to be resolved before moving on to the next one. This can lead to poor performance, and we can use an alternative like promise all to run the operations in parallel. How can you avoid callback hell in JavaScript? So you might have several asynchronous operations, and they may need to be performed in order. So callback hell will occur because you'll get this deeply nested code that sort of looks like a pyramid, and it can be incredibly difficult to read or maintain. This can be fixed by using promises or async and await keywords. On to some coding questions. Create a delay function that creates and resolves a promise after X milliseconds. So we have our function from earlier, but now it's empty. So inside of here, we will want to return a new promise. And inside of the promise, we have our executor function. And for this example, we're only going to be passing in a resolve argument. What we'll do is call setTimeout inside of the executor function. And with setTimeout, we can pass a callback as well as a delay. So we'll just pass in the resolve function as the callback, and then a delay in milliseconds. Now, if we try testing this, the delay should work. Great, now we've got one more question. Create a function that fetches data from a URL. So we have an empty function here called fetchData. We can start by adding in a try-catch block so that we can handle errors. Inside of the try block, we'll attempt to make a fetch request. Now, because fetch will create a promise, we will place the await keyword in front of it. Now, if we don't have a 200 status code, we will want to throw an error. So let's add a conditional if statement that checks if the response is okay. If it's not, then we can add the bang operator in front of response okay. And inside of here, we'll throw a new error of yikes, something went wrong. Otherwise, let's go ahead and parse the JSON response and then log the data. Now, if we run into some errors along the way, let's catch them and log their errors using console error and then logging the error message. Okay, so we can first try this out with a legitimate URL, and we can see that it works, so that's great. Now let's also see what happens if we pass a non-valid URL, and you can see that we catch the error and then log the error. And that's it for today's episode. Thank you so much for watching. Please like and subscribe if you enjoyed the video, and I look forward to seeing you in the next one.